Today we're going to start on part 2 of our how to breadboard a preamp circuit here at Blue Glow Electronics. And for some of you that have been following along with one of my other series on how to build an 807 single-ended amplifier, this schematic may look familiar to you. It's the one we're using in that build. This was the original triode dick design, and we're going to customize it a little bit for our needs, but for the most part we're trying to stick to the spirit of the original design. And if you'll notice here, I've drawn two red lines, one along here and one along here. This is what I would say constitutes, in this section, the pre-amplifier section of this amplifier. In other words, you've got to lift up the line level signal enough here to actually drive this 807 tube on the output here. And this is being done by it's actually two 6S7 tubes, but it's really not. It's two halves of one tube, which constitutes a single tube, and then half of another tube. And this would, let's just say this was the left channel. You could use the other half of this tube here for the right channel. So at the end of the build, you would actually have three 6S7s in play. One here for left and right channel, and then one here for the left channel, and then a matching tube for the right channel. But let's talk a little bit about what's in between these two red lines here. On the other side of this red line was just an input switch where you could switch maybe from CD player to iPod to maybe I don't know, maybe phono input, where you had a phono preamp on the other side of this. This amplifier stage here does not have enough gain, nor is not designed to pick up the 5 millivolts from typical from a phono stage. So we're going to pick up right here on the other side of this switch and just assume the signal we're getting here is kind of at line level. And then we're going to come in here, and as you can see here, there's a little bit of a voltage divider here between this 1K resistor and this is a 100K potentiometer. And I'll have to find the right one here, but that's a 50K, so 10K. There we go. 100K potentiometer we're actually going to use on the breadboard to replace this, and I'll use a fixed 2-watt resistor here for the 1K. We're going to feed into the grid of one of the 6S7s here to actually drive this thing. And what I wanted to do was hook up an oscilloscope here and let you watch the signal on the input. And what I'm going to do to begin with is I'm going to draw another imaginary line. Let's just pretend maybe right here. We're just going to build this stage in today's video, just this single front stage here. But I want to get everybody the ability to understand really what's going on in this little amplifier. And then we'll come along in part 3 and build the second stage and kind of wrap up the whole series here. So really you're driving the grid of this tube, which causes, a swing in the larger plate voltage here, which is going to be applied this 300 volts through this 47K plate resistor, and we'll be taking the output off of that through this 33 microfarad, 0.33 microfarad capacitor here. And we'll have to figure out what we're going to do about loading this circuit a little bit, because without this tube in here, you'd be missing a little bit of the load. The other thing we won't have in this is the we won't have the global feedback here at play because we don't have the output to feed it all the way back. But just thought I'd show you what we're going to build, and I'll reference back to this. I'll try to get it built here on the board. One thing I want to talk about real quick, and that is, I know I've got this thing laid out here on this fancy breadboard I'm going to build it on, but I'll tell you the main reason I'm building it on this board is it has an angle to it. So if you can kind of see the side of the case here, props it up a little bit. It makes it great for the video here is what it does. So it's the main reason I'm using this setup. I won't use most of the components around this thing. You could easily just as well kind of build this thing here if you had a bunch of jumpers and whatnot and had a few of these $2 little breadboard pieces, and you could actually stick them down here on a board and do this exact same thing. There's really no magic happening up here in this fancy unit I'm using. And you can see here some of the these are little jumper wires I use. They come in a pre-made pack. A box of these is about $4 or $5. You know, I use some of these flexi jumpers with the tags on the end. And you can buy these jumpers, they'll come like this in a ribbon made up, and then somebody went on the end of the ribbon cable and put all these connectors on there, and then you just kind of split them off as you need them. So if you needed, you know, 4 or 5 together to run a bus or something, you could keep them together like this. But just thought I'd show you that you could simply do it that way as well. And in the last video, you need to go back and watch it if you haven't, but I showed you how to build these little adapters that Trenton Blizzard makes, and hopefully some of you guys have picked up some of these things from him. Okay, just a tip for resistors for any purpose, or for building on a breadboard. There's these kits, and you can get them on Amazon, and they're titled Joe Knows. And what this one has is 86 values at 860 pieces, so 10 pieces of each value. Goes all the way from 0 to 10 mega ohm, and they're 1.1% metal film 1 watt resistors is what I'm going to use today. I know a minute ago I said I was going to use 2 watt, but here's the beauty of these things. They're all labeled in order. So you would have 820K, 820 ohm, 1K, 1.2, 1.5, 1.8, 2.2, 2.7. Really laid out in a nice fashion for you. And that way you can just pull out the resistor you need, pull one off, use it on your breadboard. When you get done with it, put it back in this little package, put it back in here, and you'll always have a set of standard component resistors kind of ready to go. And these things are fairly cheap. I'd have to look it up. I want to say it's about $25 for one of these boxes, but you can get them on Amazon. And I keep these kits in the half watt, quarter watt, 1 watt variation. Okay, up first what I'm going to do is feed my B plus down to the board, 300 volts, and I'm going to run it through a 47K ohm resistor, which is going to go to the plate of this first half of the 6SN7. And since I'm only using half of this, I'm going to use what's called section 1 in this tube. And if you come over here and look on a 6SN7, you've got this base diagram here, which kind of shows you the pin outs 1 through 8 here. And if you read the terminal connections, it'll tell you we're looking for the plate of section 1, so plate section 1, that'll be pin 5. So what I've done then, and I'll zoom in a little bit so you can see here, I basically came over here to the plate, which is pin 5 of this connector, and in that same little row of 5 going that way, I plugged in this 47K ohm resistor. I brought it over here to just another location where there's 5 connections right here, and I've kind of tapped in this 47K, and that's where I'm bringing in the B plus here. And then this is the other side of the B plus, the ground, and I'm going to use this strip that runs all the way down through here, this second one right here, as ground for this thing. And then we need a 33.33 microfarad 630 volt, and there we go. We keep a good selection here of just the yellow poly caps, kind of the Russian paper and oils for various little projects like this, and or repairing gear. I keep orange drops in a different bin by themselves, but I think this .33 right here will work out perfect for what we're needing to do. As you can see here, I'm going between the .33 here and between the 47K and the plate, and coming off with this 33 microfarad. So between the plate and the 47K, and I'm just going to tag it over here to a spot. And up next we need a 1K between the grid in section 1 and what'll be the center wiper on this 100K resistor. And we've got the center 100K resistor right here, and if you'll see here, I'm coming out of, oops, I missed it. I got to go up one right there. There we go, pin 4. So if you'll notice here on this, grid section 1 is equal to pin 4, and that's what I love about these things. They're laid out nice and neat. When you do it the other way without one of these little adapters from Trenton, basically you end up with a tube laying over here on the side that has, I'll give you an example, that has a set of these kind of wired off of it, off the bottom, coming over here stuck into places, and you have a hard time tracing back and figuring out exactly what pin 4 is. It's just tedious. And so I've kind of got this fed into, let's see, I might move this over here for safety purposes. And then what I'm going to do is I'm going to put this right here, and I'm going to put the center wiper where I've got that pin at. And as you can see, let me zoom in a little bit. You can see I've got pin 4 coming over here, feeding down to this spot, and then I plug the center wiper of this potentiometer right into that location. Now, if you'll notice the other side of this 100K, let's do what we need to with it here. One side needs to go to ground, so we need to grab a jumper here, and we need to take the other side of this thing, and I'm going to use this one right here, and I'm just going to feed it right over here into the section we called ground. And then the other side of it will actually be our input that we're going to use. So maybe let's use an orange jumper like this, and let's kind of tag off of that right there. And I don't know, we'll feed it down here somewhere, and that'll become our input little section right here. Okay, and finally we've got to tie the cathode of section 1 here to ground with the 1.5K. And if you'll notice, we're not going to have this global feedback loop into here, so we can kind of ignore that for now. And so if you kind of grab the data sheet again and you look at cathode section 1, you're looking at pin number 6. So we really just need to find pin number 6 here, and make sure we get into the precise spot it's in, and then from that all we got to do is tag it over here to ground. So I'm sure there's more optimal ways to lay this out. You know, if I'd have studied it a little bit, I probably could have came up with a better way, but I can tell you for right now, this is going to work out quite well. Just make sure you don't have anything touching, like this resistor and the can of this potentiometer you wouldn't want touching. So I think it's time to power this thing up and see how it works. Okay, we've added a few extra wires here, and I found one mistake, but I thought I would show you what we've done. Next up, I forgot to mention this in the last section, we have got to, and this feeds up to the Heathkit regulated power supply into the 6.3 volt AC section. We've got to feed the heaters here in pin 7 and 8 of this tube. And if you'll notice in the pin out, where did that go? There it is. You'll notice here on the little diagram, it'll tell you pin 7 and 8 here are heater and heater. So we had to feed the heaters with 6.3 volts. I found a mistake when I plugged this wire into, I kind of eyeballed it and plugged it right here. But reality is, if you get your head down under here a little bit and look, you'll see that it actually needs to go there to match up with the pin on the potentiometer. So I've added that. Let's see, what else have I added? I've added, so this, remember, this was the output right here on the other side of this 0.33 microfarad capacitor right here, right? And so I've came from that point, and I basically jumpered down here to this point, and this is nothing more than extending my jumper length. And then I'm feeding from there down here into the pin of this BNC connector right here. And then I took the shell, the outer of the BNC connector, and I ran it over here and I put it into ground. Okay, so if what that tells you is I'm going to be measuring from here to ground on the output here, and basically this BNC connection here that you can see then feeds up into channel 2 of my oscilloscope. Similarly, I came over here off of this wiper. Remember, the center wiper fed pin 4 here, which is the grid through this 1K ohm resistor. And then the other side of this potentiometer, remember, it went to ground right here. But this side, what I'm going to actually do is feed it over here to a jumper place. And then all I'm doing here is tying these two together to make my jumpers longer. I didn't have a jumper long enough to go from here all the way over here. But I'm basically going from here then into the output of my little function generator I have here on the board. I could have easily came over here and fed to this point and fed in a function generator right here, or if I had function generator with alligator clips, I could have just fed it right over here to this point. So I'm feeding to the output of this function generator built into this breadboard, but like I said, any function generator, signal generator that would give you a 1 kilohertz tone would work. And then oddly enough, I'm feeding out of this with another jumper over here to this BNC connector that I'm then feeding into this BNC cable, which is then feeding up into channel 1 of my oscilloscope. So what does that let me do? It lets me compare what I'm feeding in right here to what I'm getting out right here on the oscilloscope, and that way I can kind of compare the input signal to the output signal, and we can see the amplification taking place. So what I'm going to try to do, and I've never done this, but I'm going to try to superimpose a video taking place of the other of the camera on top of this video. We'll see how that plays out. If not, I'll just tag them in series. But so I think I've got it wired up. One thing you always want to do here once you get this done is walk away for a few minutes, go to the restroom, get a drink, do something, come back and sit down before you ever power this thing up and walk through it one more time. I mean, literally. Okay, pin 7, okay, go back to the diagram. Okay, that's a heater connection. Okay, I'm feeding that up to the heater. Pin 8, okay, that's a heater connection. I'm feeding it back. Okay, pin 4 here. Okay, that's the grid, and I'm going through this 1K ohm resistor, and I'm going to center. Just walk the whole circuit beginning to end, and walk what you've done here on this board kind of beginning to end. Make sure you've got connections lining up in the 5 rows going that way, or if you're feeding something to ground in a long row going this way, make sure you've got that all powered up as well. The last thing I'm going to do here, I'm going to feed a few connectors over here to kind of tie in. So one I'm wanting to tap into, which would be ground. So all I got to do is connect into this the other leg of the cathode, the 1.5K resistor that's coming off of pin 6 here. And then I'm wanting to connect to my B plus as well to be able to measure it, which is not hard to do, because really what I want to do for that is get on the other side of this 47K ohm resistor. So to measure B plus, all I've got to do is kind of feed up in here and leave this thing laying like this. So get those out of the way. I can put this on volts then, and I can see, and at this point I've got like basically what it's picking up, ambient noise voltage. So let's do this. I'm going to power up the Heathkit regulated power supply right now. I've just turned it on, and if you'll watch here, the voltage is climbing, and when it gets to the end of the range, you'll see it kind of jump. Wow, right, boom, boom, boom. And hey, my meter on the actual unit up here, I had set at 300. It's not far off. I'm just going to leave it right there. That's pretty darn close. It takes a minute for this Heathkit regulated power supply to warm up, and the reason for that is that it's a vacuum tube operated, so it has to heat the filaments up inside of it to ultimately drive the output regulators. And I'm going to flip this switch on, which actually drives the input at this point in time. And we'll come back and show you how that'll look here on the video itself in just a minute. So this thing's starting to come together pretty good at this point. I'll show you more here in a minute when I get the camera changed over. Okay, unfortunately I'm going to have to freestyle it, and the superimposing idea I had didn't work out so well. Came to the realization I would need 2 cameras to do that, and I don't have that handy. So you can see the setup here, nothing's really changed. I've got this turned on right now, and I've got the little unit set here to kilohertz and 1. Got the frequency up here at 1.0, which means 1 kilohertz. If you'll notice, I'm feeding down here out of that both to drive the circuit, which by the way the circuit's not powered right now. You'll notice I have no B plus over here. But it is feeding down here to this BNC pin, and if you'll notice here, I've got channel 1 right now. Notice the little yellow tag down here. Notice the little yellow tag here, channel 1. Okay, I'm feeding in here, and if you'll notice, I've got the meter. You can take the 2246, put it on voltmeter, tell it to do peak to peak, and it's actually measuring the sine wave right here, which it tells me is about 3.65, 3.9 volts. So it's kind of bouncing around a little bit. I think I need to clean the potentiometers inside of this, but it's fairly stable. And what I'm driving this thing with, and I've got both scope settings set to 0.5 volts per section here. The reason I'm driving it at about 3.7, so that's kind of line voltage. You know, I can adjust, if you'll notice here, trying not to get you sick, as I adjust this, watch what happens here. I can drive this thing pretty hard if I wanted, but I don't want to drive this thing with 1.8 volts. I want to drive it down here around 4 volts. And the reason being, so that's kind of line level. 0.5 is the max for line level, 0.3 in some cases. But you know, if you were coming out of a CD player, this is about what you'd be getting out of it, is somewhere around the 0.4 volts here. So I'm going to try to get it locked down, something right around in there. Right there, that's perfect, about 0.4 volts. Okay, so that's what we're driving the input with on this thing. And I had to turn the unit on to actually do that. Like I said, I could have fed that from anywhere else. And let's see what happens here when we turn on the B+. So if you notice, I've got the 6 volts feeding out of this down here into the heaters, and then feeding out of this, I'm feeding the B+ connection here, and I'm also feeding ground here, which is the long strip going that way. So let's see what happens on both the oscilloscope and the so it'll take a minute for the voltage to come up, because remember, the heaters have to warm up in this thing. It uses actually 2 6L6s in here to drive this thing. And look at what's happening over here. Wow. We're starting to get some output here being driven coming out of the output of this thing. So a couple things to observe here. First off, and like I said, feeding right here off the output, which is coming from here, which is feeding over here to the orange, which is coming off the other side of this 0.33 microfarad capacitor. First off, the input signal stayed the same. The output signal there, now if you'll notice, I'm going to turn off channel 1. So I'm just on channel 2 now, the output, so that my multimeter section will come along and read. We're getting an output here of about 3.76 volts. Well, if I turn that off and just watch the input here, we're down there 4.0, 3.9, 3.8. It's bouncing around a little bit. At any rate, we're about a 10x amplification on this thing right now. One other thing to note, if you'll notice, when this signal is low, this signal is high. And when this one's high, this one's low. So these signals are what are called 180 degrees out of phase, and that's normal. You'll get that. It's inversion. You'll get that going through the first stage of an amplifier, and then you'll reverse that in the second stage a lot of times, and drive it just the opposite. Let's now take a look at this little potentiometer down here. I'm going to be very careful and put my fingers on it so that I can actually turn it here, left or right. And if you'll notice what happens when I do, I'm varying the output. Remember, the input's not changing because I'm measuring it prior to getting to the potentiometer. And so what the potentiometer is doing is a voltage divider at this point, reducing the signal going into the amplifier. So regardless of what you're driving it externally, like a CD player or an iPad or iPhone, this little unit is doing a voltage divider, letting you drop the signal down on the input so that you can adjust the volume of your amplifier. And that's the way volume control works on an amplifier. And right there, it's pegged out. In other words, this potentiometer is basically out of the circuit. It's a straight through between the center wiper and the other connector there. So I'm hoping this makes sense to you. This layout's pretty darn simple if you followed it along one piece by piece. If you'll notice, we're still sitting over here at 299 volts at this point in time. You can feel this tube's got a little bit of heat to it, and that's because we've got the heaters warmed up on the inside of it. And because of the makeup of this tube, it's really hard to see that. The chrome top that covers it from here up makes it sort of tough to be able to see that. But yeah, this thing's working just the way we designed. Nice clean signal through this thing. And I thought I'd show you a couple of the tricks here. First, before I do that, I want you to watch something. I'm going to flip the switch here on this AC power supply, and I want you to watch the voltage drop on this thing. You'll notice it's taking a while, and if you'll notice, this thing's still amplifying and this power's turned off. We're still down to 40, 30 volts, still amplifying. You're seeing the signal start to drop. It's finally down to 9, 8, 7. But that took a good 20, 30, 40 seconds for this thing, and it's still, there it goes. Finally, it's stopped amplifying at this point. But the reason I bring that up is just because you turn the power off on one of these doesn't mean you won't get shocked 10, 20 seconds later. This thing's got some big filter capacitors inside of it as part of the power supply to remove the ripple that hold charge for quite a while. So just wanted you to be aware of that. Okay, what I'm about to do I would not advise for those at home. I'm going to do some measurements on this thing with the circuit on, and if you do this, please use a some type of high voltage probe like this that you can keep a good distance away. But basically I've got the black connected to ground at this point in time. You can see the multimeter set over here on voltage. And what I'm wanting to take a look at is a couple different places. So pin 6 here is the cathode, as you can see. Pin 4 is the grid, and pin 5 is the plate. So I wanted to just check out the voltages at all those locations. So at pin 4, which would be right here, if I'll notice here on the voltmeter, I get 0 volts, and that's right. You really do want 0 volts on the grid of any tube. Same as when you're feeding over here. Let me show you this real quick. Notice where this between the plate and the 47K ohm resistor is, which would be right there. If you'll notice, we're sitting at 148.9 volts. Well, you may ask, well, why doesn't the 148.9 volts feed over here and get onto the grid of this tube? Well, that is exactly the purpose of this capacitor right here. They call them coupling capacitors. It's to couple this stage to this stage. But in all honesty, I like to call it a decoupling capacitor because it's kind of decoupling this stage from a DC standpoint. So what that does is it keeps this 148.9 volts you see here from ending up on the grid of this tube and lighting it up like a Christmas tree. So interestingly, you notice I just measured something. So we've got 300 volts up here, and right here we've got 140, basically 149 volts here, sitting right here on this location. And if you remember, right here on the grid, we had 0 volts. So 0 volts on the grid right here. So let's measure the cathode right here and see what we have on pin 6 real quick. On pin 6 right there, you'll notice we have this 4.78 volts here, and let's just write that down here. 4.7, that's actually 4.77 now. It's floating around just a little bit as we work this. So 149 volts sitting up here, 0 volts sitting here DC. You actually have some AC voltage feeding through here right now because that's what we were seeing on the oscilloscope. And down here we have 4.77 volts. And this is actually the bias. This thing uses what they would call an auto bias setup. In other words, the voltage drop across this resistor is really what's biasing this whole circuit, because it makes this potential here is at 4 volts, and it makes the grid potential here at 0 volts. So you could look at that kind of the opposite, and you could say that this point has a higher potential than this of 4.7 volts, and that's what actually enables the grid to work here. Let's play with something fun here. Right now this thing's actually floating up here at 4.78 volts. So if we took the voltage here across this resistor, the cathode resistor, of 4.78 volts, and if we divided it by the value of this resistor, remember current is voltage divided by resistance, we actually end up here with 4.78 divided by 1500 equals to 0.00318. In other words, we've got 3.18 milliamps of current flowing down through this tube right here. So one thing I'll teach you a little trick, and a lot of amplifiers like Fisher, Scott, other amplifiers, they kind of tied their grids here sometimes directly to ground, sometimes they tied them back through a circuit, but a lot of times what people would do is add in a small resistor right here so that you can measure across it, and at the end of the day, if you can measure the voltage across it and you knew the amount of resistance, then you could actually calculate the current flow through it. And if you measure the current through the cathode here, you can pretty much assume that it's about the same as the current going through the plate here. So if you wanted to know what the plate current was on this tube right now, it would be somewhere around this 3.18 millivolts. Well, let's go do this. Let's actually measure the plate itself here. Let's see, right here. So here I'm sitting at 148 volts, and for math simplicity I basically did 150 volts. Divide it by the 47 k ohm resistor across here that you're getting the voltage across, and you end up with 0.003191, which is equal to 3.19 milliamps instead of 3.18 milliamps. It's in essence the same. In other words, if you want to figure out the plate current, you can either measure it at the plate or you can actually measure it at the cathode, either one. Pretty neat stuff there. Trying to think what else I could show you here. We'll take this loose. I think that's about all for now. We're going to kind of wrap this video up. You can, I'll show you one more time. I'll pick the camera up and show you the input and the output. But pretty neat little amplifier at this point in time. Okay, I thought I'd show you up here. You can see still about 10x, and then instead of varying the little potentiometer here, which I've got pegged out right now, if you notice, I can turn it down, pegged out. I'm going to come over here and drive the amplitude a little bit with this thing and see. So you could be changing the value of your function generator to vary the volume as well. The reason you don't do that is, and the reason you build a volume potentiometer into an amplifier is because not all audio sources have a variable output. Like a CD player, most of them put out a constant, 4.2, 4.3 volts, and there's really no way to adjust it. Whereas, like if you were using your iPhone to drive this, you could use the volume on your iPhone or iPad or iPod to drive that thing. So yeah, I'm pretty happy here. Actually, I've got it down a little lower. I've got it at 0.2 volts. But you can see here, you drive this thing, and let's see what it takes to saturate this thing real quick here. So we'll keep driving it, and well, this thing will. We have not reached saturation yet. There we go. Wow. Yeah. So I'm at 5 volts per division now. So if I turn off scope channel 1, this thing's putting out 34.65 volts right in there, and pretty darn clean sine wave, as you can see. So this first stage could do a whole lot more than we've got it doing, but in this amplifier design, we'll take it back down to. So let's put it on channel 1. We're driving at actually 3.3 volts. There's no audio source going to drive anything at that high of a voltage. We're back down to that 0.4 volts on the input here. You can see the output here, and I've got to adjust because notice I'm on 0.5 and 5. If I get them back to the same 0.5 scales, you can see about a 10x multiplication here on this thing. Thanks for watching, everybody. We'll add in the second circuit on the other side of this board over here for the next video. One last thing or two. I had some people make some comments that, wow, you really can't use one of these breadboards to operate at the voltages you're operating at, because they went out on DigiKey or Mauser or somewhere and found the specs on one of these boards to be only 36 volts is the most you're supposed to put into them. Well, I can tell you I've found other specs that say these things will handle up to about 100 volts, but what they're talking about is pin-to-pin voltage breakdown. So in other words, one row here to the row right beside of it. And if you'll notice, nowhere in here did I use two rows in parallel with each other. So as long as you stay away from using rows side by side for feeding high voltage, you're good to go. Because you're talking about the breakdown between two little spaces this big, and what I'm doing is I'm putting everything this big or further away. If you'll notice, that's why on these tube pinouts, the tube pins are not side by side. They're actually about 3 or 4 pins rows away from each other between each of the pin sockets on the layout. Let me find this. There it is. See how far apart these things are? They're not right side by side. So when you go to lay that down, they're actually 3 pin sockets away from each other. So we're going to put this on this side and wire up the second stage and make the third video here this weekend. And then next weekend get back to the single-ended amplifier. Thanks for watching, everybody.